I found this interesting Raspberry Pi cluster at the NAB this year. That's the National Association of Broadcasters Conference. This box has 3 Compute Module 4s, and they work together to provide audio processing, watermarking, and DSP for radio and TV stations using modern IP audio, along with multiple analog ins and outs. The box is called the Optimod, and this version could even integrate systems like EAS, or the US's Emergency Alert System, if they can get the FCC to approve some updates to the way emergency broadcasts work. But I talked to Mike and Josephat from Orban, and I asked them a few questions. First of all, why'd they put a Pi CM4 inside this thing?
Using a CM4 gives us a bunch of advantages. First off, the high-resolution screen is HDMI. Mm-hmm. Right? So you just plug that into the Pi and away you go. And the touch screen is USB.
Yeah.
So, how much mucking about do we have to do to get a UI running? It's very fast. And, usually a UI of this caliber would take, a lot.
If you're doing embedded displays and...
Yeah, well, it gets very expensive and you're not flexible, right? Because nobody wants to touch this thing once it runs. And, for us, that just didn't make a lot of sense.
So CM4 equals easier interfaces than other embedded platforms, but why have 3 of them?
Yeah. So what you have inside this box is a really complex network of audio traveling from different parts of that box. We have audio over IP, we have tons of inputs in the back, and we have HLS streams coming off the internet. So we have to be able to route the audio in different places and do different types of processing. For instance, this Pi does the watermarking processing for Nielsen, Ipsos, or Kantar. Now, the way it has to be done, it cannot be done at the end of the processing or at the beginning. It has to be done in the middle. And that added some challenges to what we had to do. So this CM4 only supports so many inputs and outputs of audio. So it's not like you can route the audio in and out and then back in and out. So we had some flexibility with the hardware we were implementing.
So are all 3 doing audio processing, or is one in charge of like display and I/O, and one is in charge of audio?
One is in charge of display, I/O, updates, and managing
so it's
everything.
like your lead controller.
Right. And the other 2 have some sort of audio processing in them.
Mm-hmm. This one is the Arbitron encoding system. You got the software, and it's dedicated to that? Is that what you were saying?
No, this is the watermarking. So this is working with Nielsen.
Nielsen, Nielsen.
Yeah.
So it's their software. You have to run their code though, right?
Exactly. We have their libraries, running in our pipes.
That one runs their code, and it just does that all the time.
Yeah.
And you patch it in and out through the audio channels as needed.
Exactly. And this was done after we shipped this unit, so we have to think really well how this had to be built before we shipped it. And so far we have had no problems with limitations on what we can do. Especially with the HD units, we have 3 different watermark streams, because we have FM, HD1, and HD2 being watermarked at the same time and at different paths. It can have different watermarks.
My dad and I discussed updates and security, and it sounds like they wanted to make sure the attack surface was minimized, so one CM4 runs Control, the web UI, and all that stuff, and the other 2 handle the critical audio processing. But those are both cut off from direct network access for security. But they've been running these things in the wild for years now, so I wanted to know if they had any problems with flash storage longevity.
Yeah, and that gives us more security. You don't want a big surface of exposed to the network. It's just what we need.
And do you use Pis with eMMC, or do you have external storage somewhere on there?
We only use they have included eMMC, There's some extra removable storage for that matter,
Has this been on for 2 or 3 years now? When was this launched?
So it was a soft launch 2 years ago, but we didn't have it was only the 5950.
Yeah.
So there was not even the 5950.
Because the question I have from that is, have a lot of people ask, with the eMMC included on the Pi, how durable is it? Yes. How many writes and all that kind of stuff?
This have been set up to have a read-only file system and only write to the Pi only when necessary, like to save presets, but not more than that.
So if you save logs or anything like that, is that saved elsewhere, or is it saved?
So you have to download your logs, and there's a special partition, on the eMMC to handle logs and all that, but it's not on the operating system partition.
Okay. I actually discussed adding in NVMe storage since the Pis have PCI Express, and maybe a future revision will have that along with even faster Pis, but that's pretty far off, I think. But it didn't sound like they were bumping into many limits even with the CM4s that they're using.
Do you need, like, how much RAM does this system need? Like, can it run on the 2 gigs or the 1 gigs, or does it need the 4, 8, 16?
It has a variety. Actually, we chose the higher end modules, like the 8 gigabytes.
To have the flexibility?
Yeah, to have the headroom. And it's overkill. It doesn't need all of it, but
Yeah.
I mean,
It's better to have
Yeah.
it.
But if you want to sell any spares you have, this is a good time to sell it.
yeah,
The
exactly.
market's gone crazy.
Right.
It-
Oh, yes, it is.
And he mentioned that the Sage system could integrate into here. Would that be virtualized on one of these Pis, or would that be adding
Exactly.
another one onto here?
No, it will be virtualized on one of these
Okay.
devices. And we already done that, not with Sage, but with other products like QUU. And we had a virtualized application that they have running inside of one of our Pis.
But I know some of you will ask, so I might as well ask for you.
What is the architectural advantage of having 3 Pis doing the 3 tasks versus having one powerful x86 chip or something like that?
Well, yes, you can use x86, but yeah, you have the power constraints, and also we wanted something that was more flexible, like having 3 CPUs in a single motherboard. That will be challenging with x86. And this way, we wanted something that was more modular. So that's why we chose to use the Pis. That way, something that might not be used for a customer might not be.
Yeah, and I
necessary.
noticed too that there's no giant fans pulling tons of air through. You just have the heat sinks.
Yeah, no, we have fans on the sides.
Oh, okay. I see there is one over here. But that's enough, and that's one of the things that I see a lot. Like
Yeah,
if you're using
exactly.
ARM chips, you're
Yeah,
not
you
going to
need
have
to pull
the
the
heat
CPU
output to
directly.
require server fans pumping the air through.
And also the form factor was a big one. We wanted one RU, and that was one of the biggest requirements.
On the theme of modularity, though, it sounds like most parts can be changed out depending on what the radio station needs in their box.
We have a dual power supply. That's where we start. And over here you have your audio VIP module, which is swappable. We have 2 variants running out right now. One specialized for Dante, and another one for AS67.
I see that's the Dante one.
Yeah, this is a Dante one. And this back here will be the streaming Pi, and this is the kind of do everything Pi. That's the one where we can add some extra features. The one in the middle will be the control Pi. Over here you have your DSP for processing audio, and this will be the watermarking Pi, which can right now supports Nielsen and Cantor and Ipsos for Europe.
Then is this all circuitry for the inputs and outputs?
Yeah, everything here is for the input and output.
Even better than modularity is repairability. Orban's been around for over 50 years, and I still see Optimods in service after 20 or 30 years at tower sites that I visit. So they know better than anyone how useful it is to use off-the-shelf parts and not block engineers' ability to get their stations back up and running after a lightning strike or a blown power supply.
It's lightning suppression,
Yeah,
Oh,
that's one.
that's not something I have to think about too much with my audio stuff.
and that's why the analog
Yeah.
balanced drivers are on dips. So when you blow it up during a lightning strike, you can just pop those in.
Okay.
And we're using the VatCorp SSM and TI compatible chips. So you can put any one of the 3 of them in the box and the performance is the same.
Ah, nice.
The other thing is this uses a pair of Meanwell medical grade power supplies. And you can buy those from DigiKey. They've usually got a couple thousand.
So you could replace one
Yeah.
in the field.
And under $20.
I mean, you don't want to sell a $500 power supply replacement unit that takes 6 weeks to ship.
I'd like to thank Orban for talking to me. This video is not sponsored. I just noticed this box had Pis in it, and they were good sports telling me more about its architecture. I think the more interesting takeaway is how they didn't care about how many gigaflops a Pi cluster could put out. It's just that the compute modules solved some of the problems they had in a rather unique way. If you want to keep up with more NAB and broadcast coverage, why don't you go check out Geerling Engineering, where my dad and I will be posting some more videos.